Have you ever wondered how airplanes fly? We live in an age where we can hop on a plane and travel around the globe, but the science behind this everyday miracle is anything but ordinary. It's a complex ballet of forces, principles, and systems working together in harmony to keep these metal birds soaring through the skies. At the heart of it all is the study of aerodynamics, the science of how air interacts with solid objects like an airplane. It's crucial to flight, dictating how airplanes are designed and operate. From the shape of the wings to the placement of the engines, every element of an airplane's design is meticulously crafted to master the forces of nature. So, buckle up as we embark on this fascinating journey to understand how airplanes defy gravity and take to the skies. Airplanes are marvels of engineering that rely on the principles of aerodynamics. Aerodynamics is the study of how air interacts with solid objects, such as an airplane. The design of an airplane, particularly the shape of its wings, plays a crucial role in generating lift. These wings, known as airfoils, create a pressure difference when air flows over them, which results in an upward force. This lift is the force that opposes gravity and keeps the airplane aloft. Now let's talk about the four fundamental forces that act on an airplane in flight. First, we have lift, which we've just discussed. It's generated by the wings and keeps the plane in the air by opposing the weight of the aircraft. Next, we have weight or gravity. This is the force that pulls the airplane toward the earth. It acts in the opposite direction to lift. The third force is thrust. This is produced by the engines and moves the airplane forward. The more thrust an engine produces, the faster the airplane can go. The fourth and final force is drag. This is the resistance an airplane encounters as it moves through the air. There are two main types of drag: parasitic drag, which includes form drag and friction, and induced drag, which is related to the generation of lift. These four forces are constantly at play during flight. For steady, level flight to occur, these forces must be in balance. That is, lift must equal weight and thrust must equal drag. So, if you've ever wondered how these massive machines manage to stay in the air, it's all about balancing these four forces. It's a delicate dance of physics and engineering, a testament to human ingenuity. Remember, for an airplane to fly smoothly, lift must balance weight and thrust must equal drag. Now let's delve into how pilots control these flying machines and the role of engines in flight. To steer an aircraft through the boundless sky, pilots make use of certain features on the wings and tail known as control surfaces. These include the ailerons, elevators, and the rudder. Let's break these down. Ailerons, located on the trailing edge of each wing, are used to roll the airplane from side to side. When the pilot moves the control stick left or right, the ailerons move in opposite directions. One goes up, the other goes down, causing the airplane to roll. Next, we have the elevators, situated on the tail of the plane. They control the pitch of the airplane, making it climb or descend. When the pilot pulls back on the control stick, the elevators rise, causing the airplane to pitch up and climb. Pushing the stick forward lowers the elevators, causing the airplane to pitch down and descend. The rudder, also on the tail, controls the yaw of the airplane, moving it left or right along its vertical axis. When the pilot presses the left pedal, the rudder turns left, causing the airplane to yaw left and vice versa. Now let's turn our attention to the engines, the powerhouse of any aircraft. Engines provide the crucial thrust needed to push the airplane forward. As the engines roar to life and propel the airplane, air flows over the wings, generating lift. The greater the thrust, the faster the airplane moves and the more lift is generated. The engines are not just about power though. They also play a critical role in maintaining the balance of the four forces of flight we discussed earlier. The thrust from the engines must equal the drag, and the lift generated by the wings must balance the weight of the aircraft. This delicate interplay of forces is what keeps an airplane steadily cruising through the sky. So in essence, the engines push the airplane forward and the control surfaces guide it in the desired direction. Flying is not just about power and control, it's also about precision and navigation. In the complex world of aviation, pilots rely heavily on an array of instruments that provide vital information during flight. These flight instruments play a crucial role in ensuring safe navigation and control of the aircraft. Let's start with the altimeter. This instrument measures the aircraft's altitude or height above sea level. It's a pressure-sensitive device, responding to changes in atmospheric pressure as the aircraft ascends or descends. For a pilot, understanding the altitude is essential for maintaining a safe flight level, avoiding obstacles, and preparing for landing. Next, we have the airspeed indicator. This instrument measures the speed of the aircraft relative to the surrounding air. It's not just about how fast the plane is moving, but how that speed affects the aircraft's performance. The airspeed indicator helps pilots maintain control during takeoff, cruising, and landing, and it's crucial for preventing stalls, which can occur if the plane flies too slowly. Then there's the attitude indicator, also known as the artificial horizon. This instrument tells the pilot the aircraft's orientation relative to the Earth's horizon. It displays pitch, whether the plane's nose is up or down, and roll, the tilt of the aircraft from side to side. This instrument is particularly useful when visibility is poor or non-existent, such as during night flights or in heavy cloud cover. Of course, these are just a few of the many instruments found in an aircraft's cockpit. There are also instruments for indicating direction, like the compass and the gyroscopic heading indicator, instruments for monitoring the engine's performance, and many more. Each one plays a role in helping the pilot control and navigate the aircraft safely. These instruments provide crucial information to pilots, allowing them to make informed decisions during flight. So next time you board a flight, remember, it's not just the pilot's skill, but also these precise instruments that ensure your journey is a safe one. Ensuring the safety and airworthiness of an airplane is a paramount responsibility that falls on the shoulders of aircraft mechanics. These unsung heroes of the aviation industry possess an intricate understanding of the complex systems that enable flight. Let's start with the engines. They are the heart of an aircraft, providing the necessary thrust for flight. Aircraft mechanics meticulously inspect and maintain these powerhouses, ensuring they are in top condition. A minor glitch in the engine can have serious consequences, making the role of an aircraft mechanic crucial in safeguarding flights. Next, we have the landing gear. It's not just about wheels and brakes. Landing gear encompasses a myriad of components, each requiring careful inspection and maintenance. From shock absorbers to hydraulic systems, aircraft mechanics ensure that every landing is as smooth as possible. The avionics system is another critical area. This involves the electronics used for communication, navigation, and aircraft control. Aircraft mechanics ensure the flawless operation of these systems, for they are the eyes and ears of the aircraft. In addition to these, aircraft mechanics work on various other systems, including the airframe, fuel systems, and even the aircraft's cabin environment. Their work is guided by strict regulatory guidelines, and they use specialized tools to diagnose and fix issues. Aircraft mechanics work in diverse environments, from bustling airports to quiet hangars. Their job is demanding, requiring a combination of physical dexterity and mental acuity. Despite the challenges, they take pride in their work, knowing that they play a vital role in ensuring the safety of every flight. So next time you board an airplane, remember the hard work of aircraft mechanics who keep these machines safe and airworthy. And that, ladies and gentlemen, is a simplified explanation of how airplanes fly. We've explored the fascinating world of aerodynamics and how the shape of an airplane's wings generates lift, allowing it to soar in the skies. We've delved deep into the four fundamental forces at play during flight: lift, weight, thrust, and drag. We've seen how pilots maneuver the aircraft using control surfaces and how engines provide the necessary thrust. We've learned about the vital flight instruments pilots rely on for safe navigation. And let's not forget the unsung heroes, the aircraft mechanics, whose meticulous work keeps these flying marvels safe and airworthy. Through understanding these basics, we've laid a strong foundation for grasping the more intricate aspects of airplane mechanics and flight dynamics. If you found this video informative and enjoyable, please like, subscribe, and share it. And don't forget to hit the bell icon for the latest updates. Safe travels and clear skies to you all.